Hi, welcome to my project video. My name is Trung. I'm a senior year student and my major is mechanical engineering. Before I start talking about my Capstone project, I would like to introduce you to my supervisor and co-supervisor, Dr. Tim Shen and Hongwei Zhuanzhu from the Motion Platform and Mixed Reality Lab. Drones, or unmanned aerial vehicles, are believed to be an emerging technology that will transform the future of many industries. However, the COVID-19 has brought to light the recent social distancing restrictions, which lead to the difficulty of studying, working in a remote environment. Remote operators will be unable to use a consumer or commercial UAVs, as often require a direct line of sight or specialized first-person viewing hardware. A virtual remote controlling system will greatly benefit operators who are in remote locations with no direct access to a drone or operating UAV in a dangerous environment. For instance, here is a short footage I found on YouTube about a guy who flew his drone above the surface of a working volcano. The drone later collided with rocks and crashes on the ground. Therefore, I want to introduce my work as a collaboration project between virtual reality and traditional drone controller. My project will focus on developing a virtual drone controller which will significantly enhance user experiences even when they do not have direct line of sight or the ability to physically present in the flight environment. To be able to do that, I have divided the project into three main challenges. The first one is the connection challenge. This task requires me to establish a strong connection to exchange data between the virtual environment and the drone controller. The second mission is to visualize the captured data from the transmission to display the current position of the UAV inside VR. Lastly, the new flying features using the ability of VR will be designed in the final task. There are several network transmission protocols which are very popular nowadays. For my project, I have chosen TCP as the tool for data transmission. Data will be transmitted between the VR engine and the drone controller method. We have several tests to make sure that both ends have responsive signal and quality data while operating the program. Here is a short video in one of our tests. The video was recorded at both sides of the system. Please note that this was happened in real time. On the left side, my combat supervisor always was holding the drone and moved around inside the optic track system at the NPMR lab. Data recorded from the tracking system were directly sent to my UT environment on my PC. As displayed, you can notice that the signal latency is very low and my virtual model reacts to Huawei movements very responsive. For visualization, I have created a simulation environment inside VR as I have shown in the previous video drone. Data transmission will be stopped whenever collision happens. User can then choose between the choice to let the system asset and automatically move the drone to sensitive location, or they can choose to manually resume the transmission and fly the drone far away from the collision. Here is a footage of me controlling the drone at the MPM lab. The first feature is the path following. This feature will allow us to draw or construct a flight path using the VR controller. There will be a set of colors that we can choose. These colors will represent the flight speed of the drone so that we can have the drone to fly with different velocities at each part of the flyway. A sample run will be visualized after the user has drawn their path using the virtual model. Here is a demo video on how the feature works in VR. While we were researching deeper on the project, we noticed that our work would need an efficient and reliable simulation system. My co-supervisor Howie has suggested me to research for a method to train a model which can be applied to predict the movement of the UAV. The reason why we have it is because drones tend to behave less predictably compared to other systems like robotic arms or ground robots, which are more stable to fall detection. Drones are by nature less stable, which would require a more complex system to occur path predict its movements, which is why the RL part may be the solution needed to solve this larger problem. Since it is the main technical contribution, my solution is the UTML, a customized package from UT to allow me training my model using reinforcement learning algorithms. Using the object tracking system from the NPM lab, we collected an enormous drone movements data file, about 10 hours in total. The outcome of this work will generate a brand model which can be used to intentionally control the virtual model follow the command of user. Here is a picture of over 500 training environments at the same time. The OL agent is manually controlling the virtual model on the right window to reach a set of data points from the track files. Originally, the project was first discussed to invent a drone controller using VR. The work would only concentrate on visualizing the flight path and develop different flying functions and features. However, as I have returned to my country when the pandemic impacted badly, I cannot physically access to the NPM lab for experiments. As the solution for this problem, my supervisor and I have started to research on different types of Internet protocols with the hope to establish a connection between my place and the laboratory for online experiment. The choice is the TTP connection. For the innovation criteria, the goal of this project will be a method which change the way we commonly think about operating a drone. These features can be used to guide people who first time experiencing a UAV model to save their time by simulating the physical characteristics of their product. On commercialization aspect, a potential goal for drone manufacturers is to implement these features as a VR experience to the customer, as the budget for a VR headset at the present time is more cost affordable than before. Finally, virtual reality promotes an invention using the simulative environment to explore the world of human imagination. Many works previously have shown that this simulative environment is also an ideally collaborative workspace between humans and robots. As users working inside the simulation environment, all the interaction with the virtual models will cause no harm if there are collisions between them and the robot. The future of this project will be development and optimization of the flying features. Further research will concentrate on discovering the potential of the project in different perspectives and approach to the industrial tasks which require high accuracy simulation and control. Also, I'm currently aiming to register my project for a PhD program. Alright, thank you everyone for listening to my presentation.